Hi, I'm Tim, and this is the 7th video in the series about anti-gravity matter. This one is actually the third of 3 dealing with spiral galaxies. This video is only an overview. If you want more detail, see the Antigravity Matter document linked to the website. So this is NGC 1300, and I want to talk a bit about the structure of this galaxy. What do we see here? We've got some spiral arms and we've got an inner bar. The spiral arms are textured and bright and globular in appearance. The inner bar is much more diffuse. And we've got some lines of dust running throughout the galaxy in the outer arms and in the inner bar. So what's going on? This structure has developed from 2 galaxies. They might have been elliptical galaxies, they might have been spiral galaxies. But either way, they both had an inner core that was dense enough to exclude all the anti-gravity matter from within a shared AGM boundary. The material in the inner core was AGM excluded. And they both had stars outside the shared AGM boundary that were in an AGM mixed state. Those stars might have been the outer region of an elliptical galaxy, or they might have been the outer core and disk of spiral galaxies. It doesn't matter. The 2 galaxies started to orbit each other. As they orbited, they generated an AGM vortex in the space in between them, and that generated an AGM lacuna. The stars in the 2 galaxies were attracted to the AGM lacuna, and tidal effects started to stretch out the 2 galaxies. The AGM mixed stars that were around the outside of the 2 galaxies were affected by anti-gravity matter drag. The drag caused their orbits to decay, and they moved forward along the developing spirals to the front. That means that what we can see in the spirals is the remains of the 2 inner cores of the 2 galaxies. These 2 inner cores are being stretched out, and they're breaking up unevenly. This is what gives the textured structure. The majority of the mass of the galaxy is still in the outer spirals. It's the outer spirals that are driving the vortex. What that means is the vortex has a structure like this. The inner end of the outer spirals is at the junction between the 2 lines on the graph. The inside of the lacuna is fairly flat, and the outside of the lacuna is the shape that we've seen before in a vortex. So that means that we would expect the orbital velocity to be fairly constant in the outer spiral arms, which is why they're being stretched out. And we would expect orbital velocity to be proportional to radius in the inner region. So, as I said before, the AGM mixed stars have made their way to the front of the spirals. There, their orbits continue to decay, and those stars make their way into the central region, but now orbital velocity is proportional to radius, so they remain in a radial structure. They create a galaxy bar. And they also remain in an AGM mixed state, which is why the galaxy bar has a diffuse appearance. The bright blobs that we can see in the outer spirals are fragments of the AGM excluded material from the previous galaxy's inner cores. They are becoming globular clusters. They contain old stars, but they are new temporary features in the new galaxy. As they continue to orbit, they'll lose stars to anti-gravity matter drag, and they'll eventually be broken up. Some of the molecular clouds from the previous galaxies have made their way forward and have descended into the galaxy bar, and some of the molecular clouds have managed to find shelter from the AGM wind behind the AGM excluded regions of the outer spirals. So this galaxy is at a relatively early stage of the process of creating one new spiral galaxy from 2 previous galaxies. In time, more material will collect towards the centre, and the vortex will be driven from there. The lacuna will lose its flat bottom, and eventually the galaxy will become more like Andromeda. It will develop drag spirals, and the disk will continue to shrink and fall into the core until eventually, if it's not disturbed in some other way, it will become an elliptical galaxy. I haven't added any more terminology, so I'll end this video there.